Hey everyone, in this video, I'm going to be going over the legal problem, insert interval. So first, let's read the question. You're given an array of non-overlapping intervals, where each element of the intervals array is its own array. So each subarray of intervals has two elements, start and end, where start represents the start and end represents the end of that interval. And intervals, the 2D array, is sorted in ascending order by start. And we're also given another interval, new interval, which is a 1D array, which contains two values, start and end. And of course, that start represents the start, and that end represents the end of that interval. So we want to insert new interval into intervals, such that intervals is still sorted in ascending order by start, and intervals does not have any overlapping intervals. And it says to merge any overlapping intervals if necessary. And it says to return intervals after the insertion. So let's take a look at example 1. Here, our intervals 2D array has two elements. The first element is 1, 3. So the start is 1 and the end is 3. And for the second element, the start is 6 and the end is 9. And new interval is 2, 5. So the start is 2 and the end is 5. And so when we merge new interval with intervals, we see an overlap between 1, 3 and 2, 5. And so that's why the output has 1, 5 as the first element and 6, 9 as the second element. So what I'm going to do in this case is I'm going to basically partition the intervals into 3 buckets. So I'm going to have one bucket called left. And for now, this will be an empty array. And the second bucket, I'll call right. And right now, this will also be an empty array. And so what I'm going to do is I'm going to loop through the intervals array. That's the 2D array. And I'm basically going to compare every interval with new intervals. And I'm going to basically have like this a couple of checks. So first, let me just do this. So I'm going to have a couple of variables. So the first two variables I'm going to have are start and end. And start and end represents like the first and second element of new interval respectively. So start is like the first element of the new interval array, and end is the second element of the new interval array. And I'll abbreviate new interval as NI in the future. And so I'm going to loop through the intervals array, right? So for SE in intervals, basically what I'm doing is like I'm looping through the intervals array. And remember, the intervals array is a 2D array, right? So every element is an array. And we know that every element consists of two elements, S and a start and an end value, right? So I'm going to have S represent like the start of each subarray and E represent the end of each subarray. And so, so now I'm going to do my checks. So if E is less than start, then we're going to put this interval in the left array. So left, so append SE. And if for elif, we have S is greater than end, we're going to append this element, or say this interval, to the right array. And so let me do a quick example of what I mean by that. So let me move over a bit and zoom out a bit. That's a bit too much. So let me do an example. Let's say that our intervals, let's say that our intervals, 2D array, intervals, look something like this. So we have 0, 3. We have 6, 8. And we have 10, 12. And let's say that our new interval is this, 4, 5. So let's look at the first element, right? Let's look at the first element, 0, 3. Well, the first thing we notice is that there's no overlap between this element and with new interval, right? Because 3 and 3 is less than 4. And so because 3 is less than 4, because the n value is less than the start value, because 3 is less than 4, we know that this entire interval is to the left of this interval, right? It doesn't we don't know where this interval is being inserted, but we know that it doesn't matter where this interval is being inserted right now. This interval is always going to be to the left of this. So this will go to the left bucket. And now let's look at 6, 8, right? We see that the start of this interval, which is 6, is greater than 5, right? 6 is greater than 5. So again, we don't really know where this new interval is going to be inserted at right now, but we know that wherever it's being inserted into, this 6, 8 interval will be after it, will be to the right of it. So that's why we put it in the right subarray. And likewise for 10, 12, right? We have 10 is greater than 5. So again, this will also go into the right subarray. Because no matter where this 4, 5 is being inserted, this 10, 12 subarray or interval will always come after this, right? So that's what I mean. So we do these checks to see where each interval, assuming there's no overlap, lies in comparison to this new interval. Like if it lies to the left or to the right. And now finally, if there is any overlap, we want start to be the minimum between itself and S, and we want end to be the maximum between itself and E. And finally, what we're going to do is we're going to return left plus start and plus right. So basically, I'm going to concatenate the arrays together, but because I have this double array here, it's going to return a 2D array at the end. And so let's go back to the code and let me type it up. So the first thing I'm going to do is I'm going to have the left and right subarrays. So the left and right arrays. Let me move this. And also, like I mentioned before, I'm gonna have our start and end variable, and this will be like the first and second values of the new interval. And so now what I'm gonna do is I'm gonna loop over the intervals array. So again, remember the intervals array is a 2D array, right? So each element of intervals is another array. So we're gonna get the start and end of each subarray with each interval. And like I mentioned, right, if E, which is like the end value of each interval, if this is for less than start, we're gonna append this interval. We're gonna append this interval to left. And otherwise, if S is greater than end, we're gonna append this interval to right. And finally, if there's any overlaps, we're gonna merge it by updating the start and end value. So we want start to be the minimum between start and S, and we want end to be the maximum between itself and E. Sorry. And finally, at the very end, we're just gonna return the 3 arrays concatenate with each other. So this is a solution. Let me just do a quick test one to make sure I didn't mess up anything. Okay, looks good. And let me submit this. And yep, you can see It's a pretty efficient solution. The time complexity is O of n because we're looping through the intervals array once. Thank you all for watching. I hope you learned something.